Haloalkane Haloarenes second part. We are just doing the Ncert conversions. Here the first conversion is from propene to propan-1-ol. This is actually the part 2 of the class. In the first part we will also do some conversions from Ncert. So here you see the first conversion is from propene to propan-1-ol. So this is our propene 1 2 3 propene, and in propene if we react this with HBr in presence of peroxide, then we will get this product CH3 CH2 CH2Br, and then this is called 1-bromopropane. And when we treat this with aqueous KOH, then we will get the our desired product, that is propan-1-ol. Here the reaction is actually SN2 reaction. Okay, this is SN2 reaction. First one is the anti-Markovnikov reaction. Here we will do the anti-Markovnikov and then we will do the SN2 reaction. Now see the second one, that is the 1-bromopropane to 2-bromopropane. So first of all you can write the structure. When you write the structure, then you can think that how can you convert this from reactant to product. So here this is 1-bromopropane, this one is 1-bromopropane, and when we treat this with alcoholic KOH, then we will get this propene, and when we again react with the HBr, then according to the Markovnikov rule, then we will get our desired product. This one is elimination. Okay, this one is elimination reaction. So first we will do the elimination and then we will do the Markovnikov rule. In the previous one, the first we will do the anti-Markovnikov rule and then SN2 reaction. Okay, now see the third one, that is from benzene to 4-bromonitrobenzene. So first we will do the halogenation of benzene, that is the bromination. So we will do the bromination in presence of anhydrous FeBr3, so that we will get bromobenzene, and we know that bromine is ortho and para directing. So when we do the nitration, then we will get the two products, that is one is orthonitro bromobenzene and another one is para-nitro bromobenzene. So we want only the para-nitro bromobenzene, so that's why we write here para bromo 1. And although we know that among para and ortho, para is the major product and ortho is the minor product, but here in this conversion we just want the 4-bromonitrobenzene only, that's why we write only the 4-bromonitrobenzene. Okay, so next one is benzyl alcohol to 2-phenyl ethanoic acid. So this is our benzyl alcohol, and in benzyl alcohol if we give thionyl chloride, then we will get benzyl chloride, and then treat it with KCN according to the SN2 reaction, then we will get 2-phenyl ethanitrile compound, and then we do the complete hydrolysis. Okay, this one is the complete hydrolysis, and when we do the complete hydrolysis, then we will get the desired product, that is the 2-phenyl ethanoic acid. Okay, now next one is the ethanol to propanenitrile. So this is our ethanol, and in ethanol if we give SOCl2, then we get this product. This means this OH group is replaced by the halogen group, and then we will do the SN2 reaction. So by using KCN, then the Cl group is replaced by the CN group. Okay, so this is our C1 2 3, so propane nitrile compound already we get. Next one is from the aniline to chlorobenzene. This is very simple. So first of all you have to do the diazotization reaction. So in diazotization reaction you will get benzene diazonium chloride, and then you will do the Gattermann or Senmeyer, anyone you can do, so that you will get the product chlorobenzene. This is our Gattermann reaction. Okay, this is Gattermann reaction. Okay, the next one, from 2-chlorobutane to 3,4-dimethyl hexane. So how can we do? This is very simple. We will do just the ORG reaction. so that you will get the product. You can see the alkyl group here. Similarly, another alkyl group, just put here CHCl, CH2 and CH3. so you will give that sodium. So sodium will take this chlorine, 2 sodium is required, and then you will get the product. This is nothing but 1 2 3 4 5 6. So this is 3,4 dimethyl hexane. Okay, next one is 2 methyl 1 propene to 2 chloro 2 methyl propane. So this is our 1 2 3. So this is 2 methyl propene. Just give HCl according to the Markovnikov rule, so that the carbon in the double bond system which has less number of hydrogen atom, in that carbon chlorine will be attached and the hydrogen will be attached in the with the remaining carbon of the double bond system. Okay, and you will get this product. Now ethyl chloride to propanoic acid. This is again very easy. Ethyl chloride, this is our ethyl chloride. Just give KCN, and according to the SN2 reaction, the Cl will replace by Cn and do the complete hydrolysis. And when you do complete hydrolysis, then Cn group, this Cn group is converted into COOH group. So this is your propanoic acid. 1 2 3 3 carbon. So this is propanoic acid. Very simple reaction. Next one is but1 to N-butyl iodide. So in but1 do the anti-Markovnikov rule, and then do the Finkelstein reaction. This is our Finkelstein reaction, so that the bromine will replace by the iodine when you give NaI in presence of acetone. Okay, in presence of acetone. So when you give NaI in presence of acetone, the according to the halogen exchange reaction, Br will replace by the iodine. Okay, this is our Finkelstein reaction. So the next one is 2 chloropropane to 1 propanol. Now see, this is our 2 chloropropane. So chlorine group in the second carbon 1 2 3, and when we do the elimination reaction, then we will get propene. And now we are doing the anti-Markovnikov rule, so that we will get 1 bromopropane, and again we do the SN2 reactions, and then we get propanol. Okay, that is 1 propanol in one position, you will get OH. That's why this is called the 1 propanol. Okay, it's very easy. Here actually you use 3 reaction. First one is elimination, and then anti-Markovnikov rule, and then the SN2 reaction. So all these reaction, first of all you have to learn from the chapter, and then you can do the conversion. Okay, next one is the isopropyl alcohol to iodoform. So this is our isopropyl group. This is isopropyl group. When we treated this with iodine and NaOH, one carbon is converted into iodoform, and the remaining 2 carbon converted into sodium salt of carboxylic acid. Okay, remember this, any one of this isopropyl group, any one is converted into iodoform, and another 2 carbon converted into the sodium salt of carboxylic acid. Remember this one, very important, very important. This similar reaction comes in NEET examination also in last I think 2021 or 2022. Okay, so very important reaction. Next one is chlorobenzene to paranitrophenol. So you know that chlorobenzene, all the halogens are ortho and para directing. So first of all do the nitration reaction, and when you do the nitration reaction, the nitro group will attach in the para position as well as in the ortho position, and we required only the para 1. That's why we write the para, and after that we will do the DOS method. Okay, DOS method, and here the chlorine group is replaced by the OH group, as NO2 group is there. That's why the condition is a little bit now easier. That is, if it is nitro group is not there, then we have to use 573 Kelvin and 300 atm of pressure. As NO2 group is there, then this reaction is a little bit easier, as NO2 is electron withdrawing group. Okay, so we already studied this in Haloalkane and Haloarenes chapter. So if you learn that reaction reactions, then you know that when you give NaOH and then followed by H plus, means maybe you can give HCl or H2SO4, so that in the first step chlorine will replace by ONa and then it is converted into OH. Okay, so this is our nothing but our DOS method. Clear? Okay, so the next one is the 2-bromopropane to 1-bromopropane, and see, this is our 2-bromopropane, and when we do the elimination reaction by using the alcoholic KOH, then we will get propene, and after that we will do the anti-Markovnikov rule, so we will get our desired product, that is the 1-bromopropane. Next one is the chloroethane to butane. So chloroethane to butane, very easy. We use the Or's reaction. So just using the Or's reaction, we will get the product. You know this, in Or's reaction, the 2 molecules of alkyl halide is required with 2 sodium atom. So you remember this one, in Or's reaction 2 molecules are required, although in the questions maybe 1 molecule given, but you have to remember that 2 molecules are required. Okay, so the next one is tertiary butyl bromide to isobutyl bromides. This is again very easy. This is our tertiary butyl bromide. How can we understand this is tertiary? The bromine atom connected with this carbon, and this carbon again connected with a 3 carbon atom, that's why it is tertiary. If the carbon atom which is connected with the halogen atom, and that carbon if connected with 1 carbon, then it is 1 degree. If it is connected with 2 carbon, then it is 2 degree, and here it is connected with 3 carbon atom, 1, 2 and 3, that's why it is 3 degree. Okay, when you do the elimination reaction, then you will get the alkene, and then again you will do the anti-Markovnikov rule, so you will get your product. Okay, now see the next the last conversion of this part, that is aniline to phenyl isocyanate. So here I write 2 method, you can use any one of them. First of all, diazotization reaction, and then we will do the Gattermann reaction. First one is diazotization, Gattermann reaction, and then according to the SN2 reaction we will get isocyanate. When we treat the halogen with AgCN, then isocyanate as product. But when you go in the amine chapter, in that chapter you will also find this reaction. This is called the carbyl-amine reaction. Okay, carbyl-amine reaction. This is from the amine chapter, that is organic compound containing nitrogen, and this is also in your class 11, the 9th chapter, I think, before biomolecules, that is called the amine chapter. And in this chapter you will do this carbyl-amine reaction. This is also very important, very important reaction, and in that reaction, by using that reaction, in one step you can form that phenyl isocyanate compound. This one is called phenyl isocyanate. If you know the name of the products and the reactant, you should write their name like that. This is aniline and this is phenyl isocyanate. This is actually the rules how to when you do the conversion, then during that you have to write their name of the reactant and products. Okay, this is actually the rules. Okay, so these are some conversions. All the conversions are taken from NCERT. Whatever the conversions are given in the NCERT, we will do in these 2 videos. In the first part you can see we will do few conversions, and here in this video we will do the remaining one. One thing always remember, one thing you should remember, that in the first video, the 4th number conversion, okay, there are some little bit you have to change, that is given in the comment section as well as in the description. Okay, you can find all these things. Okay, and in this video, if you find any kind of problem or what you want, then you can easily ask in the comment section. Okay, thank you so much.